How many of you have actually factored before, do you think? Oh, that's promising. Okay, good. All right. For today, we're just going to look at factoring out a GCF. What does GCF stand for? Greatest common factor. So that's the only part we're looking at today. Just nice, short, sweet. I'll eventually pass out to you, probably either tomorrow or Friday, like a flow chart for factoring, because we kind of look at factoring quadratics in this chapter, and then the next chapter we get into like some cubics as well. So the factor flow chart just kind of fills everything in. First and foremost, though, is your GCF. That is what we do first, no matter what. We always look for that before we start factoring anything else. So just kind of talking first about what is a common factor. So the greatest common factor is the biggest number that divides into both. So between 6 and 8, what is the GCF? It is 2. It's the only number that goes into both, right? What about between 12 and 20? 4. 24 and 36? It's 12. Now, some of you who are really great with like your multiplication facts have no problem with this. And then I have other students who use a calculator for 2 times 3, okay? So if you are somebody who struggles, probably it's an exhausting option, but it works. If I would look at like 24, I know that's 1 and 24, 2 and 12, 3 and 8, 4 and 6. Do you see how I have a nice ordered list? Keep an ordered list, okay? Then if I look at 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now I know I'm done with my list because my numbers kind of circle back the other way, right? Do you see how they just kind of go in order? So if I'm looking at my 2 lists, what's the biggest number in both lists? It's 12. So we know it's 12. Okay, it's not a fast, easy way to do that, but it is an option if you struggle with knowing what the factors are. All right, what if there's x's involved? Because you know, it's algebra. We're going to have variables in there. So what about between 2x and 6? What would you say is the GCF? First, take a look at the numbers. What about between 2 and 6? 2. Can I take an x from both? No. So my GCF is just 2. So if you're going to factor out a GCF, you have to be able to take it from everything. I always kind of take this to, you know, I always talk about I have 3 kids. Let's say they all do something together and they get in trouble. Is it fair for me to take 2 toys away from this child and only 1 from each of them? Is that fair? No, right? I got to be fair in my punishment. They all did it together. They all going to get in trouble together. I have to make sure whatever I'm punishing, I has to be the same for all of them. So same thing here. But I'm mean mom, so I'm going to take out as much as I can from all my kids, right? So the most I can take from all of them, I'm going to. But it has to be fair. So what about 3x and 12x? So between 3 and 12, it's 3. Can I take an x from both? Yeah, so this case, I can take a 3 and an x from both of them. What about 8x squared and 20x? So between 8 and 20, 4. Can I take an x from both? Can I take an x squared from both? No. So 4x. The most I can take from each of them is a 4 and just one of the x's. Does that make sense? Be mean mom, okay? Take as much as you can, but be fair. All right, so let's actually kind of practice factoring them out then. So when you are factoring, you are pulling out a GCF, it's like undistributing. You're just pulling out everything that you just did. So like if I had 2x times x minus 4, and I asked you to distribute that, what operation are you doing to distribute? You'd be multiplying, right? 2x times x would have been 2x squared. And 2x times negative 4 would have been negative 8x. So now it's like I'm giving you this, and we're going to work it back. So instead of multiplying with distributing, what's the opposite? To pull it back out, you're going to divide. All right, so I have to look and see. I have 3x plus 15. So what number goes into both 3 and 15? Can I take an x from both? No. So I'm just taking out a 3 And if it helps you, probably here in the beginning I'll write it up there for you, but eventually I'll stop writing it underneath. What you're doing is you're dividing out the 3 from each, right? So 3x divided by 3 is just x, and 15 divided by 3 is 5. Now, this is the chapter that drives me crazy when people miss these. Can you check this? Yeah. You don't even have to write it down. You can just mentally look at this. 3 times x, 3x. 3 times 5, 50. Okay, it worked. I got the same thing. Okay? I'm not changing the value. I'm just changing the way it looks. All right, what about negative 18x squared plus 8x minus 12? So what goes into 18, 8, and 12? I heard 2. I heard 4. What's wrong with 4? 4 doesn't go into 18. Yeah, so 2. Now, do you notice how this first one is negative? If the first term is negative, factor it out. That will help you so much as time goes on. So instead of just taking out a 2, I'm going to take out a negative 2. Okay, if that first term is negative, you need to take that out. Can I take an x from all of them? No, that 12 on the end doesn't have any x's, so I can't take those out. Now, be careful. This is where it really, I think, helps to see it written underneath all of these. Because if I divide by a negative 2, what am I left with this first term? A positive 9x squared. Then I have 8x divided by negative 2. Negative 4x. Good. And then negative 12 divided by negative 2. Good. And again, you can do that mental check, right? If I would distribute those back in, you should get what you started with. Now, one thing I like to point out as you're kind of going through these, sometimes we pull out a common factor, but it's not the biggest, right? Like earlier, you guys were like 6, and it was actually 12. If you did not pull out the biggest one, you'd still have a common factor sitting in here. Okay? So what I want you guys to try to get in the habit of is after you pull out the GCF, look at what's left. Is there still something common? Right? Does a 2 go into all of them? Does a 3 go into all of them? It's usually something small. Okay, just look and make sure there's nothing common still sitting there. If there is, you didn't pull out the biggest one. Okay? All right, how about that last one up there? What goes into all 3 of those? Is that a question? 3. All right, can I take an x out? No, they don't all have them. So that means I'm going to divide out this 3. And what are we left with? Good. 5x squared plus 15x minus 4. Probably the biggest thing I see students do wrong is they factor out like a 3 like that, and then they never write it down in front. Okay? I see students do it. They divide this out, and then this is like missing, and they just tell me this is the answer. Am I changing the value of the problem? No. So I should still be able to multiply this back to get where I started. If I don't put that 3 there, I've changed my problem. I can't get it back to where it was. Okay? All right, a couple more to go. 24x to the 4th minus 8x cubed plus 32x squared. What is the biggest number that goes into all of them? Oh, very nice. 8x squared. So 8 is the number, and they all have at least an x squared, right? Need Mom's taking as much as I can from all of them. And again, if it helps you, you can write this underneath. I'm dividing out 8x squared from everything. So 24 divided by 8 is 3. I had x to the 4th. I took away x squared. How many do I got left? X squared. Negative 8 divided by 8 is negative 1. And then I had 3 x's. I took away 2. I have 1 left. 32 divided by 8 is 4. I had 2 x's. I took 2 x's. They got no x's left. Now, just so you guys can see, a lot of times students tell me 4 is the biggest number. You don't have to write this down, but just so you can see it. If you took out a 4x squared, you would have been left with 6x squared minus 2x plus 8. I can take it out 4x squared, right? It goes into all of them. But take a look at inside here. What do you notice about 6, 2, and 8? They can still be divided by 2. So that's like that red flag. If I'm looking, I'm like, oh, wait, I can still divide all those by 2. That means I didn't take out the biggest number, okay? So you'd want to go back and take out the 8 instead. All right, 15x cubed plus 27x squared. What goes into both? 3x squared. Okay, if I divide these all by 3x squared, what do I have left? Good, 5x plus 9. And again, I can always distribute them back. I should get what I started with if I did it right. All right, and the last one. Ooh, there's x's and y's there. So what number goes into 20 and 35? Should I take out just a 5? Negative 5. That first one's negative, right? Take it out. So negative 5. How many x's can I take from each? How many y's can I take from each? Good. So I'm dividing them both by 5xy, or negative 5xy. That first one's negative. Always take it out. So what do I have left when I take that out? It's negative 20 divided by negative 5. It's 4. I had 2 x's. I took 1. 1 left. I had 1 y. I took 1 y. No more. Oops. All right. Then I had 35 divided by negative 5. Negative 7. Had an x. Took an x. Had 3 y's. Took 1. Good. And again, I can do that mental check. 4 and 7, nothing goes into those. No common x's and y's in both, so I know I took out the greatest common factor. How many of you are like, yeah, I learned this before? Okay, majority of you. Good. Those of you that had not learned it before, we're doing okay. I had to play that like balancing game, right? Some of you have learned this and want to like fly through it, and others have not learned it at all, so I got to kind of find that happy spot. Say that again. How would you? If you distribute it back, you would distribute here. So I would do negative 5 times 4 is negative 20. I have x times x is x squared, and I still have a y. Negative 5 times negative 7, positive 30. There was one right here. This is like one big piece that gets multiplied. So you're doing like negative 5xy times 4x. So when you multiply those two pieces together, I still have every piece. Right? Does that make sense? So same thing here when I'm multiplying negative 5 times negative 7 is positive 35. And then I have just the x, and I have a y, and a y squared is y cubed. It's like you're just putting every single piece, kind of compiling all those together. All right, other questions? Yay.